Hello to all you daisy enthusiasts. I'm Nicola Bergh from the Compton Herbarium in Cape Town, South Africa, and I'm going to be giving you an introduction to the Gnaphalieae based on this talk put together with my co-authors who are Gnaphalieae workers from across the world. Members of the tribe Gnaphalieae are known as paper daisies or everlastings or immortelles, because of their dry papery phyllaries, which are arranged in several series and form these really attractive display units of the capitulum. But the tribe's morphologically very diverse and variable, with more than 2,000 species. And so it's quite difficult to find any particular feature to which there aren't exceptions in the tribe. Nevertheless, I've listed them here. I'm not going to read through them all. I just wanted to put them up here so that they can be looked at in the recording, but I'm going to illustrate most of them in subsequent slides. But first, let's have a look at the distribution of the Gnaphalieae. This image was taken from observations in iNaturalist. So just be aware that this includes weedy species and cultivated species. But I think it gives a very good representation of the natural distribution of the Gnaphalieae. So you see they're globally distributed. But the centers of species richness are in the Southern Hemisphere, in Southern Africa, Australasia, and in South America. Economically, Gnaphalieae are used as ornamentals. So they're here at, these are shown here at markets, and this is an online sales platform. But also species such as Helichrysum italicum are used for their essential oils in cosmetics and medicine. And in South Africa, this species, Helichrysum odoratissimum, and some of its close relatives, have a lot of importance in medicine and in spiritual uses, where the dried upper portions of the plants are burnt as a kind of incense, which is known as impepo. Ecologically, the Gnaphalieae are an important component of the global temperate flora. So, for example, the species-rich shrublands of the Cape and other Mediterranean-type regions. They're also an important component of high elevation and alpine floras across the globe, such as in the East African Rift Mountains, in the European Alps, in the Himalaya, the New Zealand Alps, and in the high Andes in South America. Morphologically, my slides are very, very busy because there's a lot of variation to illustrate. So the main, in terms of growth form, the main growth form in Gnaphalieae are small shrublets, but there's also a lot of perennial herbs. There's some plants that have this interesting cushion growth form. There's also some very small annuals. These are actually sand grains surrounding this little effloga. And also they can be quite tall, robust shrubs, though that is less common. The leaves are quite variable generally, but mainly leaves are sessile, sometimes even decurrent down the stems, with entire margins. Very rarely the leaves can be toothed, but they're never deeply divided. So to the best of my knowledge, if you see leaves that look like this, you're not looking at a member of the Gnaphalieae. There are also several species that have very tiny appressed leaves or leaves in fascicles. And it's very, very common for the leaves to be hairy, at least on one surface, but also on both. And the trichomes can be also glandular on the leaves. This is the typical capitulum arrangement in the Gnaphalieae, one or just a few heads grouped together at the ends of the flowering shoots. But there is a tendency in the tribe towards capitulum reduction, where the capitula become very small, and then they're grouped together into synflorescences of various shapes. So here, for example, they're very compactly grouped into these spike-like synflorescences, and these are completely unrelated taxa. Here in Seriphium, where there's just one floret per capitulum, the capitula are arranged in these spherical glomerules along a flowering axis. And then in the genus Udera, there are true secondary heads where the capitula are modified and grouped in such a way that they resemble one capitulum. And that whole structure is then surrounded by a pseudo-involucre made from the upper leaves. The phyllaries that are so characteristic in Gnaphaliae and often make up the showy part of the capitulum, because very few Gnaphaliae have ray florets. In Gnaphaliae, we call this basal part of the phylary the stereome. It's often thickened or cartilaginous, and this is the portion that can bear glandular or eglandular trichomes. The apical portion of the phylary is thinner and papery and often brightly colored. This forms the showy part. And when the phylaries are arranged in series from outer to inner, you can see that the stereome and the lamina make up different proportions of the phylary, depending on where it is in the series. The capitula are usually disciform, in which case there's two kinds of florets in the head, an outer peripheral ring of female florets with filiform corollas, and then the central florets are hermaphrodite with tubular corollas. But you do also get discoid heads quite commonly, in which case all the florets are tubular and hermaphrodite. In this instance, there's glandular trichomes on the backs of the corolla lobes. And you do also get radiate capitula, as I mentioned. So this is Bergh, where there's one ray and one disc floret per capitulum. These are the involucral bracts. And the pappus comprises capillary bristles and scales, or just bristles or just scales. And the bristles can be nude to barbellate to plumose, or long plumose all along the length. And the scales are various sizes, and there's various varying degrees of fusion of the scales when they're present. The typical style branches in the Gnaphaliae are truncate at the tips with apical sweeping hairs. Quite rarely they can be rounded to acuminate. And the stigmatic lines are marginal along these branches. And when the branches are truncate, they're parallel right to the end, so they're apically separated. And the anthers are ecalcerate and minutely tailed. Cypselae in the Gnaphaliae are small, generally barrel-shaped. They can be unornamented, or they can have sparse or dense coverings of epidermal trichomes, the typical daisy duplex hairs. And these trichomes can take various shapes, from elongate to clavate to very globose. Okay, so what do we know about the phylogenetic relationships within the Gnaphaliae? Whole tribe phylogenies are based on Sanger-sequenced gene trees, and these can be problematic because of incongruence between the gene trees. So we generally struggle to reconcile these different gene trees, even though there are many clades or grades that are consistently recovered. We're not completely sure of the membership of some of these clades. There's often low support around the backbone of the tree, and so we don't have a full understanding of the relationships of these clades to each other. And also there's a few taxa that are in different places in different trees or unplaced, difficult to place. However, we have two clades that are consistently recovered in every phylogeny to date. And so we've used these to erect a new subtribal classification for the Gnaphaliae. The one clade is the Ralhania clade, which we formalize as subtribe Ralhanianae, shown here in purple, and it's sister to all the remaining species, which we've put in this enlarged concept of the Gnaphalianae, where really the bulk of the species diversity in the tribe is placed. Now I'm going to run through the diversity in the tribe using a nuclear ribosomal DNA phylogeny, but I'm going to use this one, which was produced by Zelongni and colleagues, because they did an ancestral area reconstruction in their analyses. And so they've colored the branches according to these broad geographical areas. And I think that makes a very nice way to go through the variation and the geography of the various clades. So I'm just going to talk about the major clades in the Gnaphaliae. And the first one is the subtribe Bergh. And you can see that it originated in Southern Africa, and most of the variation is still in Southern Africa, except for the genus Phagnolon, which has diversified in the greater Mediterranean area. So the area of these circles are proportional to the number of species in each genus. And these small circles with no numbers in them have only got one species. So these are monotypic genera. And the Bergh has got about 120 species in 11 genera. And morphologically, they're non-uniform within the Bergh, but also a lot of the species have quite atypical morphologies for the tribe. So although many have entire leaf margins, which is a typical feature, they can also be dentates, as in this pentatrichia. They often revolute around a white woolly abaxial surface. And although the capitula usually have peripheral female florets, which is typical for Gnaphaliae, in the Bergh, unusually, those female florets are usually radiate, and the rays can be yellow or pink and white. Although there are also species with discoid or hermaphrodite florets. And the disc floret style arms can be truncate, which is the typical feature for Gnaphaliae, or they can be rounded or even acuminate, in which case those stigmatic lines meet at the apex. Okay, on to the other subtribe, the Gnaphalieae, where most of the variation is housed. And you can see that most of the divergences along the backbone are inferred to have occurred in Southern Africa, in the Gnaphalieae, which is quite interesting, although it's also true for several other asteroid tribes in the daisies, interestingly enough. So the first clade I'm going to talk about is what I call the Sim clade, comprising the Stiebiefloga and Metalasia clades, all localized in Southern Africa. In fact, mostly in the Cape region, the winter rainfall region, although some members of the Stiebi clade get into tropical Africa and Madagascar. And there's about 150 species in 16 genera, with the largest genus being Metalasia. And these species are characterized by a very unusual form of secondary thickening entailing a pericyclic cambium in the stem. The leaves are generally ericoid and twisted, and the margins are involute around a white woolly adaxial surface, which is exactly the opposite of what was in the Bergh, interestingly enough. Some genera have rays, as you can see here, and there's quite a strong reduction in floret number in some genera in this clade, to just 1 or 2 per capitulum in Diceborough, Stiebi, and Seraphium. The next clade I want to talk about is the Hap clade, named for the large genera Helichrysum, Anaphyllus, and Pseudognaphalium. And this is really the largest clade. The Helichrysum, these red branches here represent African helichrysums, and also in the tropical African highlands and Madagascar, these helichrysums. And then a Chirocline, diversified in South America. The genus Pseudognaphalium is nested in here, and that's very widespread. And then Anaphyllus, which is distributed across Asia and North America. And then these branches here represent the Mediterranean helichrysums. So despite not being monophyletic, the genus Helichrysum is the largest, or perhaps because it's not monophyletic. And there's several other large genera as well in this clade, like Gnaphaliese and Gnaphalieae. Very, very large clade with more than 800 species. Here's the type of Helichrysum and an illustration of Gnaphaliese and Pseudonephalium. And this is a Helichrysum with very showy tips to the phyllaries. But what's interesting about the hap clade is that there's a very strong morphological synapomorphy, which is that the stereome, this basal portion of the phylary, is fenestrated or divided, which means there's a thin area around the veins, which is visible under the microscope when the hairs have been cleared away. And this is not found in non-hap clade members like Gnaphalium here, where same image, but there's just no fenestration there to the stereome. And here's some more illustrations of a Madagascan Helichrysum and a Chirocline from Africa. The Gnaphalium clade is a smallish clade which also originated in southern Africa, and some of the species are quite widespread, many in the genus Gnaphalium, which is the largest, although it's generally quite a small clade here with just, as far as we know, around 50 species. And as I mentioned, the stereome is undivided in this group, although sometimes there's some thin streaks at the base of the lamina, which has been taxonomically confusing in the past. The apices of the phyllaries are opaque and usually whitish or cream colored, and the leaves are quite hairy with strictly entire margins. This is Acaranthemum from the Cape, and South African Plecostachys and Gnaphalium, and Gnaphalium from Kenya. The flag clade is named for the large genera Phalago, Leontopodium, Antenaria, and Gammakita. And it's quite interesting because the ancestor and the early divergences in this clade are inferred to have occurred in Europe, and I think mostly the northern Mediterranean area. And the genus Phalago is distributed in Europe and North America. Leontopodium diversified in Asia. Gammakita across the Americas. And then Antenaria is in the Northern Hemisphere and in South America. And there's also some very widespread species indicated by the black lines. Quite a large and diverse clade with 360 species. And quite a few annuals with very, very interesting forms. The iconic Edelweiss, Leontopodium Gnaphalieae, is in this clade, as well as Antenaria, Gammakita, and some other very beautiful and interesting species. The sea clade is not represented as a clade here, but I'm calling it a clade because in some other analyses with greater sampling within these genera, it does come out as monophyletic. And this is a exclusively Cape clade, quite small, with about 50 species. All of them are perennial, with quite felty leaves, often with quite large capitula. The leaf margins can have these rust-colored hairs in the genus Syncarpa. They generally have fimbrillaferous receptacles and pappus bristles that can be plumose at the tips. And in Syncarpa and some of the related genera, the cypsela trichomes are very rounded and globose and have quite an unusual cellular structure. Now, this sea clade is sister to this large Australasian clade. And so based on these relationships, it looks like what happened is this was a single dispersal event, a long distance dispersal event from Southern Africa directly to Australia. And that seems to have given rise to this really remarkable radiation, very regionally confined radiation in the Gnaphalieae. And it's very, very diverse, this clade, with nearly 600 species. but also morphologically extremely diverse. And I think that's why these species have been segregated into so many different genera, because they really are so different from each other, and they explore such a range of morphological shapes and patterns. And many of them are annual, and ectomycorrhizal formation is common in many of these species. And you can try to illustrate here some of the large range of the curious morphologies that they explore. Some of them have ray florets, and there's a large range of growth forms, leaf anatomies, including cushion plants, and interestingly enough, the species Leucogenes grandiceps, which is endemic to New Zealand, and I think you can see the convergence, apparent convergence with the Edelweiss, and so it's not surprisingly known as the South Island Edelweiss. And then this very interesting monotypic Calameria amaranthoides with these very small capitula arranged in these very lax inflorescences, pendulous capitula looking most un-Gnaphalieoid. So I hope that's given you an idea of the variation in the Gnaphaliae in this rather interesting tribe. And you can see the growth form varies. I think almost every single clade here has got both annuals and perennials and a range of growth forms. Some very, very interesting biogeographic patterns as well, with Southern Africa being extremely important in the diversification and origin of the tribe, and then multiple range expansions out of Southern Africa, perhaps overland in many instances to seed radiations in the Northern Hemisphere where the tribe is spread, and then also colonized South America, and then also potentially long distance dispersal to found this amazing radiation in the Australasian region. And I'll just say thank you very much to the workshop organizers, and I'm very much looking forward to the rest of the talks. Thank you.